Welcome to This Explainer. We're going to skip the agenda today because, honestly, we just need to jump straight into something totally wild that went down in October 2025. Picture this, a scientific conference, specifically the Stanford Open Conference of AI Agents for Science. Now, at this event, artificial intelligence wasn't just allowed in as a helpful little tool. It was literally required to serve as the primary author of the research papers. And if that wasn't crazy enough, AI systems also acted as the peer reviewers. So what we're looking at here isn't just a minor update to how things are done. It is a fundamental restructuring of the scientific process itself.
Okay, let's dive into this. Are researchers actually being replaced by artificial intelligence? It's the question absolutely everyone is asking right now. But as you'll see from the sources, replacement isn't about human scientists packing up their desks and simply disappearing from the lab. Instead, we're looking at a profound, fundamental shift in daily roles. The whole landscape is moving away from the researcher as a creator and heavily toward the researcher as a curator. So the intellectual heavy lifting, that's increasingly outsourced. But the responsibility? Well, that remains entirely human.
To really give you a sense of the sheer velocity of the shift, I want to hit you with this shocking data point: 20,000. During its inaugural week alone, the Stanford Agentic Reviewer processed over 20,000 research papers. To put that into perspective, human review panels couldn't even dream of hitting those kinds of numbers in a single week. It's a real game changer. It shows us that AI isn't just assisting anymore, it's operating at a massive scale that completely rewrites the speed limit of scientific evaluation. So, moving on to Section 1, automating the scientific life cycle.
Behind the scenes, we're moving way past those single-function, isolated chatbots you might be used to. This new era is powered by agentic AI. Unlike a standard chatbot that just waits and responds to a prompt, agentic systems are large language models that actually plan, reason, and act across complex, multi-step tasks. Now, do they truly reason? That is actually a matter of fierce debate right now. Back in June 2025, Apple dropped a paper called The Illusion of Thinking, where they argued these models just hit a complexity cliff and basically fail. But literally within days, other researchers fired back. They argued that what looks like a lack of reasoning is actually just an agentic gap, basically a limitation in tool use restrictions and context windows, not a true cognitive incapacity. But regardless of how they're doing it under the hood, these systems are executing incredibly complex workflows.
If we lay out the traditional scientific life cycle, ideation, planning, execution, creation, and sharing, we can visually anchor exactly where agentic AI is intercepting the process. It's kind of like a giant puzzle, and AI is fitting into every single piece. We've got tools like PersonaFlow jumping into ideation, DataDreamer generating synthetic data, and even crazy systems like Manus that can automatically replicate entire research papers from just a single prompt. AI is stepping right into every single phase of this cycle.
And this brilliantly illustrates exactly how this breaks down in practice across different categories. Literature review is for sure the most mature use case right now, with tools like Web of Science and ScienceOS summarizing and mapping out huge topics. Then for hypothesis planning, we see things like Outkin K-Navigator in biomedicine. For data analysis, you've got tools like Elicit Pro. We even have systems like WinGrants AI writing full end-to-end grant proposals at the European Union level. It is a complete functioning automation ecosystem.
Which brings us to Section 2, from creator to curator.
Just think about it for a second. If an AI generates your hypothesis, writes your code, conducts your entire literature review, and then drafts the manuscript, you're no longer the primary creator. And the absolutely crucial point is this: AI expands throughput, but humans must ensure validity. As a creator, you're the one drafting, coding, and synthesizing original thought. But as a curator, your job is totally different. You're orchestrating agents, verifying their outputs, governing the process, and applying scientific judgment. The intellectual generation gets outsourced, but the ultimate scientific responsibility, that remains strictly, undeniably human.
Now, what's really interesting about this slide is seeing just how granular this curation gets in practice. What we're looking at here is an AI assistant pulling highly structured, traceable methodology directly out of complex PDFs on quantum batteries. It's not just giving us some vague summary, it is extracting the exact methods, stuff like local projective measurements, and structuring them neatly into a database. The human researcher doesn't need to manually sit there, read, and tag 50 different papers anymore. They just need to curate and verify the database that the AI built for them.
And honestly, it goes way beyond just extraction into actual rigorous evaluation. This shows how literature evaluation is shifting over to LLMs using specific multi-criteria scoring. You can literally ask an AI agent to score a paper from 1 to 5 on method novelty, domain alignment, and practical applicability. The AI does the heavy reading, it does the scoring, and it pushes the human even further into that orchestration and oversight role we talked about. Let's move on to Section 3, the attention bottleneck.
So this massive expansion in throughput creates a brand new, very human problem. We simply cannot keep up. We are entering what's called the economics of attention. Think of it this way. When generating a hypothesis or writing a paper becomes practically free and instantaneous, verification suddenly becomes the expensive, rate-limiting bottleneck. Anthropic's data perfectly highlights this. If an AI agent can write 10 plausible code patches in a single hour, the limitation is no longer the coding itself, right? The bottleneck is the human reviewer's time to actually sit down and check if those patches are safe, valid, and actually work.
And add to that this absolutely staggering reality. There are over 100,000 research papers published every single week. That is a staggering amount of information. The information overload is just immense. Our finite human capacity to actually filter, reproduce, and integrate this exploding amount of knowledge is being strained to the absolute breaking point.
This takes us to Section 4, Risks of the Curator Era. Right, so this brings us to the darker side of this transition. The sheer volume of AI-augmented submissions threatens to completely overwhelm our traditional scientific standards. And these risks are massive and compounding fast. We're seeing peer review flooding. In fact, a recent analysis suggested that up to 21% of the reviews at the ICLR 2025 conference might have been AI-generated. At NERBS 2025, over 50 accepted papers were found to have hundreds of AI-hallucinated references. Hundreds. We're facing data pollution, where AI models train on AI-generated junk, which leads straight to model collapse. We're seeing this weird decoupling of publication counts from actual scientific progress, creating a system where people just gain the metrics. And perhaps most dangerously of all, we are facing the erosion of foundational educational friction.
The erosion of cognitive competencies in the next generation of scholars. I really want to let that sink in for a moment. There is a very real fear here. By removing the educational friction of doing the hard, manual, grinding work of literature reviews and coding, future scholars might learn how to operate the shiny new tools of science perfectly, but completely lack the fundamental logic to question paradigm-shifting anomalies. If they don't do the groundwork, they might not be able to spot when the machine is confidently, entirely wrong.
Let's move to Section 5, True Human-AI Coexistence, and see how this builds toward a solution.
Because look, the goal here isn't to just ban these tools. They are way too powerful and frankly way too useful for that. The real goal is safely governing this new era, and the answer seems to lie in the human-in-the-loop model. We need to actively teach what are called orchestration skills. This means teaching students and researchers things like decomposition, prompting, deep review, and judgment, specifically the judgment of knowing exactly when not to delegate a task to an AI. We need personal, reproducible AI pipelines where the human researcher defines the core goals, verifies the reasoning, and carefully curates the final outputs. In some frameworks, we might even start seeing AI properly credited as a co-author, which would bring some much-needed full transparency to who or what actually did the intellectual work.
Which leaves us with this final, deeply provocative thought to ponder. If an AI performs all the heavy lifting, generating hypotheses, running data, and synthesizing critical insights, what truly remains of the human researcher's value? Are we willing to trade the inherent, messy, human joy of doing science for vast scientific breakthroughs that we can verify, but perhaps no longer truly understand? It's a profound shift, it is happening right now, and it's something we all need to be thinking about. Thanks for joining me for this explainer, and I'll catch you in the next one.